x is y is equivalent to a raised to y equals x. A raised to y equals x. But not with anything in front. So in this case, I have to move this where it came from the power of h. So log h to -1 equals p. And now I can apply this rule. The base is 10. We don't write 10. By convention, we know it's 10. 10 raised to p equals that. 10 raised to p equals h to -1. Write an equivalent expression, exponential equation. So that's the equivalent. Good. Anything else? Very good questions. Anything else you would like to look at?
On page 422, could we do problem 41?
49 and 422?
Yes.
Very good.
Wait, 41, sorry.
No worries. 41 and 422. Very good. 422, 423, 41. Very good. So this is the integral from, is it this one? Am I correct?
Yes, that's it.
I see index 5. Is that it? Yes. Okay. Good. So I will start with denoting 1 plus 6x squared by u, and du is 12x dx. And I already see what's happening here. This is du. So then the integral becomes the integral from u to 1/5 du. Please make sure you do not write an integral with two variables in it or two functions in it, right? So if you write x or something in here and u at the same time, that's incorrect. So when I move from x, I completely move from x to something else, in this case to u. I can't have a mixture of u and x in any integral, please. So this is u to 1/5 plus 1, which is 6/5, over 6/5 plus a constant c. Yes, I have to flip the fraction. And I have to change u now into what it was, because this is an indefinite integral. The answer has to be presented in the variable given in the problem. Good, very good questions. Anything else?
Can we look at number 33 on the same page?
Yes. 33 on the same page. 33, where is my book? 33. Yes. So this is the integral from dx over x natural log x. And of course, x has to be greater than 1, of course. Because otherwise the denominator will be 0. Good. So here we have one option will be to write u, which is natural log x, and du equals 1 over x dx. Do I have it? Of course, I'm looking at it. This is du. So then the integral becomes 1 over u du. Because natural log is in the denominator, this is the u, so 1 over u du, dx over x. Either written as 1 over x times dx or dx over x is the same thing. So this is natural log of the absolute value of u plus a constant c, and now I have to plug it back in. Don't forget the absolute value anytime the answer is natural log, or log, right? But that's what we know. We know natural log. Good?
On that same page, could we do problem 40?
Yes. 40. Yes. The integral from 3x squared dx, everything over 1 plus x cubed squared, I think. Am I correct? No, it's not squared. It's the fifth. Is it power 5? Yes, it's power 5, right? Good. So again, the same thing. U equals 1 plus x cubed because du equals 3x squared dx. So this is basically the integral from du over u to the fifth, which is the same thing with the integral from u to negative 5 du, which is u to negative 5 plus 1 over the same number plus a constant c. And yes, I have to go back and write 1 plus x to the third to power 4. It's negative here, it's positive here in the denominator. Any questions?
On page 509, could we do number both 6 and 13?
6 and 13?
Yes.
Very good.
Thank you.
509. I just passed it. 509. Okay, number 6. So in 6 we have y prime. I'm just now checking my memory. I think we did this, but I'm checking my memory. It's not, I'll do it as many times as we need, but I need to check my memory. If we did this last time. Nothing to do with you. I am checking my memory.
Oh, okay. Sorry. I forgot
That's
what
okay.
to do.
I still have to do it?
No, you're good.
Okay.
I was going through trying to figure out what problems I needed, and I hadn't looked at the videos.
That's
yet.
okay. No worries. No worries.
Thank you.
And 13, we did 13 together, but we can, which one do you want to do? They're all the same, A, B, or C.
Can we do A?
Okay, so we have y equals e to 6x. So in order to show or check whether this is a solution or not, we have to determine the second and the first derivative and then plug them in and see if we get 0. So y prime would be 6e to 6x, and y double prime will be 36e to 6x. So I replace 36e to 6x minus 6e to 6x minus 30 times e to 6x. If this is 0, I will say yes. If this is not 0, then I will say no. But 36 minus 6 and minus 30, because they're all like terms, will be 0. So then I will say yes, it is.
Thank you.
Sure, my pleasure.
I can't remember. How would we do C with both?
Oh, it's a linear combination, exactly the same. So
Oh, okay.
you have to do the same thing. You find the first derivative, the second derivative, and plug it in.
Oh, okay. Would you just plug in?
Yeah,
all
let me
of them?
let me at least show the first derivative if you want.
Okay.
So y prime will be 6c1 e to 6x minus 5c2 e to negative 5x. And the second derivative will be 36c1 e to 6x plus 25c2 e to negative 5x. And you plug them in.
Oh, okay. That makes sense. Thank you.
Yeah, everything the same.
On page 5, 10, with the like problems 47 through 52, I know there's two different types.
You said on 510,
Yes.
47 through 52?
Yeah, like what are the two different types again? Like the directly and inversely?
Yeah, so y equals kx or y equals k over x.
Okay, and which one's which?
This is the direct. They go in the
Okay.
same direction, and this is inverse. If one increases, the other one decreases.
That makes sense. Thank you.
Thank you. Anything else? So again, this is direct. In other words, one increases, the other one decreases, and this is inverse. One increases, the other one decreases. So this is inverse. Anything else? Anything else? Well, if you don't, yes?
Oh, I had one more.
Yes,
Okay.
of course.
Page 455, number 22.
455.22. Number 22. Okay. So let's see what it says. It says d of x equals 15 minus, I think it's 1/3 x. Correct me if I'm wrong. And s of x equals 2 the cube root of x. And it says, find the equilibrium point, identify the regions of both consumer and producer surpluses. We can do that. And find the consumer surplus and find the producer surplus at that at the equilibrium point. Okay. So we can graph these, but first let's find the equilibrium point. So when d of x equals s of x, so 15 minus 1/3 x equals 2 the cube root of x. We have not done anything like this with the cube root because we have to raise everything to the 3rd power in order to solve. So the formula for this to the 3rd is a to the 3rd minus 3a squared b plus 3ab squared minus b to the 3rd. So you will not have to do this because it takes a long time. And the right-hand side is not going to be a problem. The right-hand side is 8x. But the left-hand side, I have to use this to raise it to the 3rd power. So I have 15 to the 3rd. I have minus 3 times 15 squared times 1/3 x and plus 3 times 15 times 1/3 x squared, which is 1 over 9 x squared. And this is minus 1 over 27 x to the 3rd, and this is 8x. Huge calculations here. And of course, we have to plug it in to solve. So
We don't have to do this problem if it's going to take too long.
So this is all this work is just for finding the equilibrium point. This is just for the equilibrium point.
That's
Okay.
a lot.
So 15 to the 3rd, 3375 minus, there is no point in simplifying because I need to multiply by 27 anyway. So even if I simplify, let's simplify, but so this is minus 225x. And here I have 5 plus 5x squared minus 1 over 27x cubed minus 8x equals 0. It's okay, so 3375 minus 233x plus 5x squared minus 1 over 27x cubed equals 0. I don't have to do anything, just put it in the graphing calculator and find the solutions. One of them has to be real, at least one. So we go to apps 9. Okay, polynomial, but this is degree 3. And carefully in the correct order, the first coefficient is negative 1 over 27. The next one is 5. The next one is negative 233. And the next one is 3375. Okay. And that's exactly it. So here, see, Still, the 86 is better. 86 gives the complex solutions as well. This one does not. Ha. Okay, so x equals 27. If I show you my 86, 86 will list all 3 solutions because it's degree 3. It has to have 3 solutions. So x equals 27. So now I have to find, so the cube root of 27 is 3. 3 times 2 is 6. So the equilibrium point is 27, comma 6. So at this point, the consumer surplus will be the integral from 0 to 27 from this 15 minus 1/3 x dx and minus 27 times 6. And the producer surplus will be, 27 times 6 minus the integral from 0, I'll erase that in a minute, from 2 the cube root of x dx. So this has to go away. Since we know how to calculate all this, allow me to just use the, which I never really do. The second class I showed this because it's not that I don't trust it, it's because that students sometimes have difficulties plugging it in and it's a big mess after that. So 0 to 27 and 15 minus, careful, parentheses, 1/3 x dx. Okay, yep. And then minus 27 times 6. And this is the consumer surplus, $121.5. Now the other one, I have 27 times 6 and minus from 0 to 27 from 2 times x to power 1/3. Okay, so this $40.4999.